Okay, now that you are done analyzing your results, the next step is to interpret them. And to help you do that, we have a couple of considerations as a guide, starting from quantifying your uncertainty, thinking about how your result compare with the literature and a lens of equity, right? Okay, so we'll start with quantifying your uncertainty. You just want to check how confident you are about your results. For instance, if your results were measured, right, how consistent were your measurements over time? Did you observe any trend, any, fluctuations? Can you describe where these fluctuations came from? Or rather, if your result was modeled, how sensitive is the model parameter to changes? For instance, if one of your model parameter was model resolution, right? How would changing the model resolution impact the entire result, right? And remember that correlation does not imply causation. If two parameters are correlated, it does not mean that one parameter is impacting directly on the other parameter. There might be additional parameters that are actually the underlying cause of this fluctuation for both of these two parameters, right? You are studying, so you need to take, note of them. All of this is to define the uncertainty, which does not in itself diminish your research impact. As a matter of fact, clearly quantified uncertainty will strengthen your sign by building more confidence. Okay. And the next thing is think about, comparing your work with existing literature. Here, you just want to put your work side by side with the existing body of knowledge to see if your work is in agreement, aligning with, previously accepted knowledge, or if it is contradicting. If it is contradicting, you want to ask yourself, can we explain why there are differences? Right. So, because on this, we also want to think about how our work is advancing scientific discourse. For instance, is this the first study using a particular analysis method or measuring a certain quantity? Okay, for the example project, we could say that previous research had shown that carbon dioxide um, absorbs heat from the radiation, right? And our project is the first to measure how much the temperature increases as a result. Okay, the next thing there is a lens of equity. Here, just want to know who is represented by this data and who is not represented. Okay, so because a lot of time, climate scientists will be studying something that impacts a particular population. It is important to think about which population might be impacted so that we can make sure to communicate our findings, our results, our recommendations to that population. This is to help them make informed decisions based on the result. And when interpreting the data, are you aware of your own value judgments? You might tend to focus more on data that has direct impact on you while you ignore data that have direct impact on others. If many people keep focusing on data that have impact on a certain population, of course, that will bring in inequality, and we should try as much as possible to avoid that. Um, and the next point to consider is whose previous results do we compare us with, and therefore we'll have to cite. Okay, there are a lot of scientific results out there, and only a small portion of them amounts to the majority of citations. This can mean that good science and, of course, good scientists, good researchers are overlooked. Citations are therefore an important part of advancing scientific career. So thinking about who might, be overlooking is important to advancing equity and making sure that all good results are recognized, right? And these are just a few things we can help you interpreting your result. I can.